Hello everybody, this is lesson 1 of the lecture International Financial Markets. I will discuss slides 1 to 29. Before we start, let me give you a short overview of chapter 1. We will start with a repetition of some basic microeconomic concepts. In section 1.1 we will discuss the reasons why people make savings or investments and how capital markets can help to coordinate savings and investment behavior. In section 1.2 we will discuss why most people do not like risk and how financial markets can help to reduce risks. The last section of this chapter deals with some basic mathematical procedures used to evaluate prices and returns of financial market assets. Okay, so let's start with the question why people make savings. There may be lots of reasons to make savings. We are looking now for the more economic ones. Making savings means consumption today is postponed in favor of consumption in the future. Why are people willing to give up consumption today in favor of consumption in the future? The standard microeconomic answer is because they receive interest payments for their savings. Some people might also save, let's say for a rainy day or to have a retirement provision, but they will offer this money to capital market only if they receive an interest payment, because they will typically demand a compensation for the default risk. We will come back to this problem later. The standard assumption in microeconomics is therefore that the willingness to save depends positively on the interest rate. As a result, the savings supply curve has a positive slope, as this diagram shows. In this diagram we measure the interest rate on the y-axis and the money offered at a given interest rate on the x-axis in euro. So this savings curve has a positive slope, and that means the higher the interest rate, the higher the savings volume offered. For example, if the interest rate is just 4%, then the savings volume is between 6 and 7 euro. Now, if the interest rate grows from 4 to 8%, the savings volume is larger because of this positive slope. It's somewhere between 14 and 15 euro. Why do people save more when they receive higher interest payments? The standard microeconomic answer is higher interest payments allow for higher consumption in the future. This compensates for the lower consumption today. How does this affect consumption of households? The relationship between savings today and consumption today is inverse. The budget constraint of a household shows this. If you neglect the necessity to pay taxes, the simplest form of a budget constraint is given by the following equation. Income is used either for savings or consumption. All income which is not spent for consumption purposes is automatically saved. If you spend more for consumption purposes. As you have income, savings will become negative. So, in a sense, this budget constraint is unavoidable. Everybody of us has, if you like it or not, such a budget constraint. If you use shortcuts, we typically symbolize income with capital letter Y, savings with capital letter S, and consumption with capital letter C. Now if we change this equation a little bit by subtracting savings from this side, then we can isolate consumption on one side, and we see that consumption equals income minus savings, of course. Now, if we say that savings is positively influenced by the interest rate, then a higher interest rate will automatically increase savings. If savings become larger, then more is subtracted from income, and as a result, there's no other chance. The remainder, consumption, will fall. So a higher interest rate causes lower consumption. If we make the assumption that a higher interest rate causes more savings. We symbolize this with a plus sign below the interest argument in the savings function and a negative sign below the interest rate in the consumption function. The result of these considerations is that in such a diagram where we measure on the y-axis the interest rate and on the x-axis volume of consumption, the consumption function will have a negative slope. This means if the interest rate is high, for example 8%, then consumption is relatively low. If the interest rate falls to a level of, let's say, 4%, then consumption grows to a level of about 11 euro. How does an increase of permanent income now affect the savings function? Well, we can use the budget constraint to analyze this question. If we increase income, y gets larger, so it must increase savings and or consumption. Most likely is that it increases both savings and consumption at the same time, because a permanent increase of income means that higher income will also be available in future periods. So people have no reason to postpone all additional consumption into the future. What consequences has such a permanent increase of income for the graphical exposition of the savings function? Households will save more at every interest rate. Therefore, we should observe a more or less parallel shift of the savings function to the right. As a result, at every interest rate, savings supply is now higher, as the green arrow demonstrates. As a rule, if permanent income of household grows, households will typically save more. Therefore, household permanent income is a shift parameter of the savings function. If permanent income grows, we have to shift the savings function to the right. If permanent income falls, we have to shift the savings function to the left. Now let's have a closer look at the motives why people make investments. Investment means to spend money today to buy capital goods which are assumed to yield a return in the future. The more capital goods are used in production, the higher is the real output of goods and services. This increase in real output makes investment profitable. However, the productivity of an additional investment normally decreases with an increase in the volume of investment. Investment projects can therefore be ranked according to their expected return. This results in the following investment curve. Here we measure again on the y-axis the interest rate and on x-axis the total investment volume in money terms, in this case euro. Let's assume we have one relatively small investment project with a relatively high expected investment return. This is ranked in first place. A second investment project with the second largest investment return needs somewhat more capital. Hence, this rectangle area is somewhat broader. We rank all investment projects now according to their expected return. So every rectangular area represents one investment project. Now let's assume that the market interest rate is for some reason equal to 8%. How many investment projects will now be realized? Well, if the market interest rate is 8%, only the first investment project is profitable. All other investment projects will not be realized. How many investment projects would be realized if the market interest rate is 2%? Well, of course, at an interest rate of 2%, the first 5 investment projects will be profitable. Only the expected return of the last 2 is too small at an interest rate of 2%. If we add the savings curve to the curve of available investment projects, we can recognize how many investment projects savers are willing to finance. They will finance every investment project which provides an interest rate at least as high as the savings supply curve. Consequently, 1, 2, 3, 4, the first 4 investment projects will be realized. Hence, the equilibrium interest rate will be on this level here, a little bit below 5%. Since some investment projects have a higher return than 5%, investors will have a surplus from their investments equal to this dark green area. Savers will receive a total interest payment equal to the investment volume, 9 euro, times the interest rate. nearly 5%. Consequently, these interest payments are represented by the green surface of this rectangle here. Okay? If we subtract from this surface the payments, the interest payments necessary to compensate savers for their foregone consumption sacrifice, it is the area below the demand curve. If we subtract from this surface the payments necessary to compensate savers for their foregone consumption, that is the area below the demand curve, we receive this red triangle which represents saver surplus. Consequently, investors as well as savers keep a net surplus from their cooperation over the market. An exchange of savings and the resulting equilibrium interest rate is therefore usually beneficial. In the following, we will, for simplicity, approximate the curve of investment projects with a simple straight line, like this. The market interest rate is then given by the intersection point between the savings function and the investment function. Saver surplus and investor surplus are represented by these triangles. Contrary to the savings curve, the investment curve has a negative slope. Consequently, the lower the interest rate, the higher the demand for savings capital. The investment curve is also influenced by shift parameters, for example, the expected return of investment projects. If firms expect on average higher returns on investment projects, for example, because of an expected higher demand for their goods, the investment curve shifts to the right. If firms expect a lower return on investment, they will typically want to invest less, and therefore the investment curve shifts to the left. The intersection point between savings and investment curve yields the equilibrium interest rate. We can use this diagram to analyze how investment reacts, for example, if household income grows and causes more savings. So if household income grows, we have to shift the savings function to the right. As a result, the intersection point will now lie on a lower interest rate level. Since the interest rate falls, a larger credit volume is therefore demanded, and hence more investment projects are realized. Or we can also analyze how savings supply react if investors expect higher investment returns and increase their investment credit demand. In this case, we have to shift the investment curve to the right. This yields an intersection point now at a higher interest rate level. As a result, households will save more as before, and companies or investors will have additional funds to realize additional investment projects. This shows that markets act also as a kind of communication system where demand side and supply side exchange information. Okay, so much for this lesson. In the next lesson we will discuss people's behavior towards risk.